Alright, now question 2. Corn stover from a corn to ethanol plant is being burned in a boiler and produces 750 kilowatts of thermal energy, of which 70% is transferred to the boiler tubes that generate steam for the plant. Water enters the boiler tube at 30 degrees Celsius at 1 bar and leaves as saturated steam at 25 bars absolute. A. Calculate the rate in kg per hour. Okay, take note of this, kg per hour, at which steam is produced. B. What is the volumetric flow rate of this steam? And C. What is the volumetric flow rate if ideal gas law behavior is assumed? So we draw out our system here. We have the one coming in, okay, and coming out, okay, and it produces a so we have Q, which has a 70% efficiency, okay, 70% of the thermal energy from 750 kilowatt is transferred to the boiler tubes, okay, which gives us Q to be 525 kilowatts. Now from table B.5 we can obtain that H1, the enthalpy in the inlet here, based on the condition where at 30 degrees Celsius and 1 bar, okay, is 125.7 kilojoule per kg. So using the same method from this part here, and we continue to obtain H2 from table B.6 at 25 bars absolute. This gives us H2 to be equal to 2800.9 kilojoule per kg. So at steady state, the change in kinetic energy is equal to the change in potential energy, also equals to the work done, and that equals to 0. It's steady state equals to 0. So therefore, the change in enthalpy will be equal to the heat transfer, okay, Q. So this is actually the mass flow rate multiplied by your change in specific enthalpy, okay. The only difference is because of their units, right? That gives you 525 kilowatts. So M here is actually 525 divided by the change in H, which is H2 minus H1, the out minus the in, and that leaves us with 0.1962 kg per second. Now the question wants you to calculate the rate in kg per hour, so we simply convert it to hour, okay, and that gives us 706.5 kg per hour. Now for part B, now using table B.6, the specific volume for saturated steam at 25 bar is 0.0799 meter cube per kg. So therefore, to calculate for the flow rate, we simply take the specific volume, multiply by the mass flow rate of the steam that is produced, and that gives us 56.4 meter cube per hour. So this is just a simple conversion of the steam, the units, into meter cube. Okay, and we need to use the specific volume for that. So for part C, using table B.6 at temperature 223.9 degrees Celsius, okay, so we know that PV equals to nRT, and we arrange it, we get our volumetric flow rate to be nRT over P. So V here, sorry, this should be n. Okay, so V here is 39,250 mole per hour, multiplied by your R, multiplied by your T, which is here, convert them to Kelvin, divide by 25 bar, okay, and that gives you this. Sorry, yeah, this one should be N, my mistake, and I apologize for that. Okay, so that's all.